square roots are a funny thing. If you type, say, the square root of 25 into your calculator using this button here, you'll get 5. But if you, say, type the square root of 2 into your calculator, you're going to get this really long, horrible number that goes on and on for ages. So if we're asked to do sums with square roots that we may not necessarily be able to break down, example, root 45, how would we be able to do that without using a calculator? Our first question here is to reduce root 45 to its lowest form. Whenever we're thinking of surds, it's really important that we focus on the square numbers. I think that's really important because, of course, this is actually a square root, but we don't actually focus, or we don't actually write the square root. So root 45 is what we're asked here to write it in its lowest terms. And on the side here, I'm going to write my square numbers. So my square numbers here are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 6 squared 36, and so on. I'm going to focus on number 45. So I'm looking at these numbers here, and I'm thinking, okay, what numbers can I multiply here to get 45 that involve a square number? And hopefully you're thinking, all right, well, I could write root 45 as root 9 times 5, because I can see 9 here is a square root number. Okay, so I've written it's root 9 by root 5, or root 9 by 5. Another way I can rewrite that is I could say, well, it's root 9 by root 5. Now, hang on a minute. The square root of 9, can I rewrite that as something else? I can, surely. I can write that as 3. So 3 root 5 would be the lowest form I could rewrite root 45. Okay, so now here we're asked to simplify the following. Now, it's very similar to indices in the fact that I can't really add or subtract or do anything like that until I kind of have them all not in the same base, in this time kind of, I suppose, in the same square root. So along the side here, I'm going to write down my square numbers. So I have 1 squared is 1, 4, 9, 16, 25, 36, 7 sevens are 49, and so on. So 50. Really, when I'm looking at 50, I'm thinking this one here. So I could write it as root 25 by root 25 by 2. Okay, so that was fair enough. 8, well, 8 really I can only write as 4 really. So I could write that as 4 by 2. So that's a plus, and minus this one here, 32, 16 times 2. That's how I could write it there. So if I was to rewrite that, then that'd be root 25 by root 2 plus root 4 by root 2 minus root 16 by root 2. And I should know that the square root of 25 is 5, so that becomes 5 root 2. I can't break down root 2 anymore. If I typed root 2 into my calculator, I'd get a really long number, and I'm going to do it here on the side. So I'm typing in square root of 2, and I'm getting 1.414, so really long one. But this one here I can do, and then I have this root 4, so I'm going to call this, well, I should know straight away that it is 2 root 2 minus, and then this would be 4 root 2. And then I can now add up or subtract. So I have 5 root 2 plus 2 root 2, which is 7 root 2, minus 4 root 2 gives me a final answer of 3 root 2. So simplifying, being aware of all of these square numbers, filling them in as I can, and then realizing the pattern that I've filled out root 2 everywhere, which means I can add and subtract. Okay, and then that brings us to the learning check. So you have 3 questions here, simplify them. So see if you could break them down, very similar to the first example I gave you. And then the second question here, root 50 plus root 8, how would you add and subtract those? You can only do it if they've got the same square root. So could you use your square numbers to get them to add? All right, and I'll see everybody tomorrow.